Actually, we got a look at some captivating pictures as we peer back close to the start of everything. The James Webb Space Telescope has lately disclosed a revelation that challenges our understanding. This revelation has delighted the interest of space specialists and analysts, insinuating a perhaps immense occasion equipped for changing the universe as we currently see it. The meaning of this finding is significant, raising requests in regards to the genuine reason for our galactic presence. The request arises: could this disclosure at some point lead toward the farthest reaches of all that we know? Is the universe on the edge of a pivotal occasion beyond our current comprehension? Join us as we dig into the latest divulgence from the James Webb Telescope and examine the likelihood of it reshaping our appreciation of the universe. Our venture begins with an appraisal of the recognizable universe, or rather a window into the monstrous spread past the perceivable universe. It incorporates all that we can perceive, measure, and dissect with our telescopes and space missions. It is a combination of stars, inestimable frameworks, and wonderful bodies visible to us, tending to just a little part of the entire universe. A small piece of a huge, tremendous puzzle that individuals endeavor to study and handle. Despite our advancements, the general size and design of the universe remain a mystery. The distance across the conspicuous universe is evaluated to be roughly 93 billion light-years. This shocking figure results from various components, including the distance light can travel in one Earth year. The age of the universe, estimated at 13.8 billion years since the Big Bang, induces that the perceptible universe expands 13.8 billion light-years in each direction from Earth and has a width of around 93 billion light-years. However, Hubble's law shows that space has been developing since the Big Bang, causing the visible universe to likewise broaden. Current evaluations propose that objects emitting light quite some time ago from a distance of 13.8 billion light-years are now around 46 billion light-years away. This advancement suggests that the discernible universe grows in excess of 46 billion light-years in each direction from Earth. The gigantic augmentation, initiated by a strong explosion billions of years ago, has not only prompted the universe expanding but also accelerating. Confounding forces like dark energy seem to be driving this speed increase, extending the universe's limits further apart. As the universe broadened, gravitational forces pulled particles together, achieving astonishing designs like stars, galaxies, and planets, including our own Earth. Not enduring the perpetuation of the universe, innovative types of progress have allowed individuals to incessantly research a greater measure of it. Specific telescopes, including the Hubble Space Telescope and the James Webb Space Telescope, have enabled the observation of distant stars and frameworks, making these wonders more accessible to the general populace. In considering the limitless field, it is interesting to note that even within our broad local group, the universe appears strangely void. The nearest star, when cut back to the size of a quarter, would still be about 2 soccer fields away. This magnificence extends just inside our Milky Way galaxy, one of billions in the observable universe, offering us a brief look into the vastness of colossal size. As we continue with our examination, the new exposure by the James Webb Space Telescope adds another layer of interest to our understanding of the universe, inducing further requests regarding the nature of our presence and the potential for remarkable events on a limitless scale. You might be curious about why we can't see the entirety of the universe. There are a couple of reasons for this limitation. Despite light being the fastest entity in the universe, it still requires time to traverse space. Consequently, when we observe distant objects, we are essentially looking into the past. The farther an object is, the more its light has traveled to reach us, creating a sort of cosmic time machine that stretches the actual history of our universe as we witness galaxies millions, if not billions, of light years away. Another pressing factor at play is the expansion of the universe. Imagine the outer layer of an inflated balloon covered in dots. As the balloon expands, the dots move apart, much like galaxies drifting away as the fabric of space expands. This expansion results in a phenomenon known as redshift, where the light emitted by far-off objects undergoes a shift in wavelengths, stretching toward longer red conditions. Some massive bodies ultimately reach a critical distance, with their light being too far away to reach us due to the continuous development of the universe. Considering these two critical elements, the travel time of light and the expansion of the universe, it's not surprising that we haven't seen the entire universe yet. Even with the most advanced telescopes and technology, our vision remains restricted by the fundamental components of the universe. Let's dive deeper into these concepts. The size of the universe is a moving target, assessed in light years to indicate the distance light travels in a year. Our galaxy, the Milky Way, spans around 100,000 light years. Indeed, even within our reality, the closest star to our sun, Proxima Centauri, is around 4.24 light years away. When we investigate space, we can see worlds billions or even trillions of light years away, allowing us a brief glimpse into the early history of the universe. The mystery of the universe's edge has captivated the interest of individuals from various fields. While specific arrangements remain elusive, three gigantic hypotheses have emerged. The first proposes that the universe is timeless and gigantic, with no clear endpoint, expanding eternally. The second suggests a limited universe without an obvious edge, like a vast round or twisted space. In this scenario, traveling endlessly in any direction would eventually bring one back to the starting point, much like circumnavigating the Earth. The third hypothesis, the multiverse theory, presents the possibility of our universe being one among many, each with distinct physical laws and properties. These universes could operate independently or be interconnected, shaping an enormous and complex multiverse. Exploring these hypotheses sparks both scientific and philosophical interest. The notion of an infinite universe challenges our view of space and its vastness, while a limited universe without an edge challenges our thoughts about boundaries and progression, suggesting the potential for repeating patterns within the fabric of space. The multiverse hypothesis, with its parallel universes, opens up possibilities beyond our current understanding, showcasing realms very different from our own. However, it's crucial to note that these ideas remain theoretical and elusive, awaiting further examination. Investigating the universe's edge presents significant challenges, making it difficult to validate or dismiss existing theories. The boundlessness of vast space, combined with the limitations of our observational instruments and technology, creates obstacles in unraveling the mysteries surrounding the universe's boundaries. Amid this cosmic uncertainty, the James Webb Space Telescope emerges as an encouraging sign, promising to shed light on the puzzling origins of our universe. The JWST stands out as a game-changing device, offering unparalleled accuracy in observing the universe. This groundbreaking instrument has the potential to reveal the clandestine history of our universe, providing insights far beyond our imagination. Crafted as a technical marvel, the JWST has recently made outstanding revelations, particularly in the investigation of the universe's edge. One of the striking discoveries includes the identification of 6 gigantic galaxies dating back between 500 million and 700 million years after the Big Bang. Published in the journal Nature, this research challenges established theories about the beginnings and evolution of galaxies in the early universe. Remarkably, these ancient galaxies show aspects significantly more pronounced than expected for their age, defying assumptions and altering the narrative of cosmic development. Contrary to initial beliefs of observing microscopic youthful galaxies, astronomers were astonished to find these immense cosmic entities. The mass within these ancient galaxies is staggering, with some potentially possessing a total mass up to 100 billion times that of our Sun. The JWST's unparalleled ability to unveil the universe's secrets lies in its use of infrared light, which is invisible to the human eye. This capability allows the telescope to detect faint emissions from ancient stars and galaxies, revealing countless remnants that have endured for billions of years. Acting as a time machine, the JWST transports our vision back through time, providing significant insights into the universe as it existed around 13.5 billion years ago. The new discovery of massive galaxies, dubbed universe breakers, has transformed our understanding of cosmic evolution. These unanticipated revelations challenge previously held models, investigating the common belief that galaxies began small and grew steadily over time. The James Webb Space Telescope, with its high-resolution photos and spectroscopic methods, has played a critical role in unraveling the mysteries of these colossal worlds, surpassing all expectations. The possibility of extremely massive black holes lying beneath these galaxies adds another layer of mystery to the cosmic fabric. Even when considering just a portion of the data, The known mass of stars in the universe may now ultimately depend on a dazzling multiple of times more than previous estimates. This discovery prompts a significant reassessment of how we interpret infinite mass and structure, with each new revelation contributing to our grand map and offering a more detailed picture of the universe's history and evolution. The repercussions of these massive galaxies extend beyond their size, challenging fundamental ideas and instigating a reevaluation of how we might interpret cosmic evolution. The James Webb Space Telescope has played a huge role in advancing our understanding of the universe to sensational levels through its cutting-edge technology. One remarkable discovery by the JWST is the identification of the most ancient and most distant galaxies ever observed. These galaxies transport us to a time when the universe was just a tiny fraction of its current age, existing shortly after the event known as the Big Bang. What adds to the intrigue is that the light emitted by these galaxies left on its journey over 13.4 billion years ago, finally reaching our observation from the perspective of the JWST. The earliest pictures captured echo the early looks of the Hubble Space Telescope, revealing various potential galaxies. The early observations from the James Webb Space Telescope have ignited a new wave of excitement among researchers, particularly regarding the formation and evolution of galaxies. These discoveries are not merely incremental changes. They also represent a paradigm shift in our understanding of the universe's early stages. By analyzing the light from these distant worlds, astronomers can study their true properties, such as their mass, size, and star formation rates. This information is vital for grasping how galaxies, including our own Milky Way, formed and evolved over time. The JWST's advanced instruments, including its near-infrared camera, NIR-CAM, and near-infrared spectrograph, NIR-SPEC, have provided remarkable clarity in observing these ancient astronomical structures. These instruments capture light from the earliest galaxies, some of which existed only a short time after the Big Bang. By analyzing this light, scientists can extract an abundance of information about the conditions of the early universe. The data suggests that these early galaxies were significantly more advanced than previously suspected, exhibiting complex structures and high rates of star formation. Furthermore, the discovery of such massive and mature galaxies at such an early stage raises intriguing questions about the processes that led to their formation. It challenges existing models of galaxy formation and evolution, which generally assumed that galaxies would evolve from much smaller, less complex origins. The rapid formation and evolution of these galaxies suggest that the early universe was fundamentally more dynamic and complex than prior models proposed. This finding requires a reassessment of our hypotheses about the circumstances and processes that might have led to the rapid evolution of these early cosmic structures. Moreover, these observations provide new insights into the distribution of dark matter in the early universe. Dark matter, which does not emit light or energy, is believed to play a crucial role in the development of galaxies by influencing their structure and evolution through its gravitational effects. The massive galaxies identified by the JWST may offer clues about how dark matter contributed to their formation and development, potentially revealing more about the nature of this elusive substance. The JWST's ability to capture detailed spectra of distant galaxies also allows scientists to study the chemical composition of these ancient massive structures. By analyzing the light from these galaxies, researchers can determine the presence and abundance of various elements and molecules. This information helps scientists understand the processes of chemical evolution in the early universe, shedding light on how the first stars and galaxies contributed to the formation of the complex cosmic landscape we observe today. The implications of these discoveries extend beyond merely enhancing our understanding of the early universe. They also influence our awareness of the broader cosmic scene by providing a clearer image of how galaxies form and evolve. The JWST is aiding in answering key questions about the universe's history and the forces that shaped its evolution. Each new piece of information from the JWST brings us closer to unraveling the mysteries of the universe, offering a more complete and nuanced understanding of our plaque as the JWST continues its mission. Future discoveries are likely to further refine our knowledge of cosmic evolution. The telescope's ability to peer deeper into the universe's past will undoubtedly lead to even more profound revelations, potentially changing our understanding of the universe and our place within it. The new revelations made by the James Webb Space Telescope, JWST, have ignited significant interest among researchers and scientists, especially concerning our comprehension of the universe. The JWST discoveries challenge long-held beliefs about the formation and evolution of galaxies, and one of the most interesting aspects is its ability to observe ancient galaxies, some dating back to just a couple of 100 million years after the Big Bang. This understanding allows astronomers to study how galaxies formed and evolved during the early stages of the universe. The size of the perceptible universe is immense, estimated at around 93 billion light-years in diameter. Despite the amazing advancements in technology, much of the universe remains beyond our reach. When we observe distant objects, we are essentially looking back in time, as light takes years to travel from these celestial bodies to us. This phenomenon creates a kind of cosmic time machine, revealing the universe's history as we witness galaxies millions or billions of light-years away. The expansion of the universe adds another layer of complexity to our understanding. As the universe expands, galaxies move away from each other, leading to a phenomenon known as redshift, where light from distant galaxies shifts to longer wavelengths. This has implications for how we perceive the universe and raises questions about its ultimate fate. Researchers have proposed several hypotheses regarding the universe's structure, including the possibility of a multiverse, which suggests that our universe may be one of many, each with different physical laws governing their development and evolution. The JWST has identified massive galaxies that are more advanced than previously thought for their age. These discoveries challenge traditional models that proposed galaxies developed from much smaller beginnings. The identification of large, mature galaxies at such an early stage suggests that the early universe was more dynamic and complex than earlier models suggested. Moreover, the JWST's ability to capture infrared light enables it to detect faint emissions from ancient stars and galaxies. This capacity reveals insights into the composition of these early cosmic structures and the role of dark matter in their formation. Dark matter, which does not emit light, is believed to be crucial for understanding the gravitational forces that shape galaxies. By analyzing the chemical composition of these ancient galaxies, scientists can gain a better understanding of the processes that led to the formation of the first stars and galaxies. The findings from the JWST are not just incremental changes. They represent a paradigm shift in our understanding of cosmic evolution and challenge existing models of how the universe developed. As the JWST continues its mission, future discoveries are likely to further refine our understanding of the universe, revealing new insights into its past and the forces that shaped its development.